Greetings, fellow grade 10s. It's Mr. Shachara again. Look, now what we are going to be looking at today, we are looking at trigonometry of 2D shapes, and the paper, or rather the question paper that we are examining, it is our November 2016. So this is the past paper that we are looking at today. Now let's try and understand what does this question basically require us to do. They say, look, the diagram below represent a cross section of the peak of a table mountain. They say T and the lion head L above the sea level. Now they say points M and N directly below the peak, and L and T respectively, such that your MPN lies on the same horizontal plane at the sea level, and P is directly below C. Now, what you're given that MN is 3,100 meters, then the angle of elevation, of L is given by beta, and the angle of elevation of T, it is given by your theta. Now, it is given that your tan of theta, it is 0.35, and your tan of beta is 0.21. Now, the first thing that they want us to do is they want us to represent the ratio. Now, they want us to represent what is going to be now the ratio of LM is to TN. Now, let's look at this way. Now, what is it that you are going to do? Now, if you can start here. Now, from here, let's look at your LN, right? Let's start with your LM. Now, your LM is basically this side, right? Your LM is basically this side. And now, if you can try and look at this triangle LMN, right? So if you can just look at this triangle, right? Just look at this triangle and try to express our tan of beta in terms of the side. What is it that you are going to do? Look, now what we're going to do is, look, we want to express this, and now we want to start with the LM because that's the one that we are looking for. So basically, it's more like we are expressing our side LM, which is going to be our unknown side, and our MN, because we are given what is our MN, to find out what is going to be the expression of both of these sides. So now for 7.1, what we are going to do, we are going to say, look, now your tan of beta, right? Your tan of beta here, it is going to be equal to, remember that for tan, it is opposite over adjacent. Now the opposite side, it is what? It is LM over what? Over your what? All over your MN. All over your MN, right? Your MN, that's going to be the representation of tan beta. So basically what they are saying here, they are saying this tan of beta, which is 0.21, it is the representation of MN, of LM, divided by your MN. Let's write this one nicely so that you see it. So we are saying, remember, for you, if you had to find what is your tan of beta, it was going to be LM over MN, which means basically this 0.21, because they are saying this is your tan of beta. It is the representation of what? Of LM over MN, which means both of these things are 0.21. Your LM over MN is represented by 0.21. Hopefully now this makes sense. Let's look at the other one. Now let's try and get another color there that is nicer. Now let's look at this one. Now let's wipe here. So if you are now looking at this other big triangle, your triangle, this one, right? Now if you can look at these triangles and you look at it carefully, now we want in this triangle to express your theta in terms of tan, right? Now, for you to express your theta in terms of tan, now look, you are going to say, look, your tan, remember tan is opposite over your adjacent, right? So which means now, even here, your tan of theta for this one is going to be, what is the opposite side? Your opposite side is Tn. So it is Tn divided by the adjacent side, which is your Mn. right? And remember here you are given that your tan of theta, it is 0.35. So which means this ratio, it is given by 0.35, right? Now that is going to be that ratio. And now because they said you need to represent these things now in terms of ratio, right? In terms of ratio. So what is it that you are going to do now? You are going to take the first side now. If you can represent now these ratios because they are represented, if you can just come and present these ratios. Now, look, we are going to say now, look, your LM over your MN divided by what? Divided by TN over your what now? Over your MN. Now we want to find out what is going to be the ratio of both of these. Now, and for us now to find the ratio, remember we started with LM divided by MN. So what is LM? Remember LM is given by this coefficient, which is 0.21, right? So this is going to be 0.21 divided by 0.35. Isn't it so? And now what is it that you're going to get now when you are doing that? Look, now if you are doing that, the response that you're going to get now automatically now, let me show you something. If you are dividing LM over MN, you can still change the division into multiplication sign. And when you're multiplying, this is going to be same as your MN over your what? Over your TN. And this one and this one are going to cancel, which means what you're going to be left with, you're going to be left with LM over your TN, which is what you're going to be left with in here. So which means now your LM now over your TN, it is going to be what? When you're dividing these two things, what is it that you found? Now this is still going to be 0.21 divided by 0.35. Isn't it so? And now, and when we are solving this, when we are trying to solve this, this is going to be same as 3 over 5, right? So which means now this 3 over 5, let me undo that one. This 3 over 5 can be expressed in terms of ratio, right? So which means the 3, it is obviously for the LM, and the 5 is for the TM. So therefore, which means now the ratio, your LM is to TN is same as now what is going to be your the first one. The first one, it was given by 3 is to 5. So basically now this is the ratio that represent both of those things, right? Now hopefully this will make sense to you. Now let's look at your 7.2 now 0.1. Let's try and get another nicer color there. Now they say a cable car C travel from the top of the Table Mountain T following the path TCM, TCM, which is going to be this particular path, right? Now, what is it that they want us to do now? They say calculate the angle formed at MTN between the cable and the vertical height TN. So now what? Now they want us to basically calculate, what is going to be this angle formed, because it is an angle formed between your MT and your TN, right? And now to find what is going to be this particular angle formed, what is it that you are going to do? Now, and in this case now, we are not necessarily going to find this upper angle, right? But the angle that you are going to be seeking to find, it is basically it is going to be, you can start by finding what is going to be this angle in here, and then you can come back and find out the angle that you are looking for. And remember, don't forget that this is going to be your 90 degrees here, right? So now what is it that now we are going to do here? So we are going to say, look, now your tan of theta, if you can start by finding what is your tan of theta. Your tan of theta, you are given that it is equals to what? It is 0.35. And now, which means when you say theta is equals to shift tan of 0.35, this is 0.35. The theta that you're going to get in there, it is going to be your 19, what, 29 degrees, right? This is going to be a theta. And now when you are moving from there, now what is it that now we are going to do? Now we are going to say, look, if you found this as 19 comma what 19,29 degrees, you know that this angle here plus this angle here must give you 90 degrees, right? So which means now the angle that you're looking in there, which is your angle which is your angle MTN, which is this angle. So your angle MTN, in this case, it's going to be your 90 degrees subtract your 19.29, right? Uh, and then now what is going to be that? Now this is going to be given by 70,71. So that is going to be what this 70,71 degrees, which means this is same as 70,71 degrees that you're going to find in here, right? Now hopefully this will make sense to you. Now let's look at the last question. Now they say if the cable car C travels along the cable such that TC. Now let's make up some space there so that you can see when we plug in all this information back to these equations, right? Let's just remove all the things that we've already dealt with. Now, what we are looking to find here, now this question, they want you to do what now? They want you to calculate the height of the cable car above the sea level at that instant. Now they want you to calculate what is going to be the height, and which means in this context, basically they want you to calculate what is going to be your height CP. Now in order for us to get our height CP, what is it that we are going to do? So now our point of focus now, it is going to be limited. Now what our point of focus that we are going to do now is we are going to now firstly calculate what is going to be your side TM, right? So you can start by calculating what is going to be this side here, your side TM, right? And now how can you then calculate your side TM in this regard? Now there are many things that you have. For this one, look, you are having the side that is adjacent, you are having the angle, and you are looking for our hypotenuse side, right? So which means the trigonometric ratio that you are going to use here, you are going to say, look, for 7.2.2, you are going to start there to say, now firstly your T, your cos, this is going to be your cos of 19,29. It is going to be close to what? Now this is going to be close to the adjacent side. And remember the adjacent side is 3. It's same as 3,100 or 3,100. It's going to be divided by, remember that cos it's car, which is adjacent over your hypotenuse, which is going to be your MT, right? Which is going to be your MT. Now let's try and solve this so that we minimize space. Now, which means now if you are multiplying in here, your side MT that you are going to find in here, it is going to be what? When you plug in here, it is 3284,39, which means basically it is 3,284,39 cent, right? So now this is going to be this longer line MT. And now that we found that, now that we found out, remember what we are seeking to find, we want to find out what is going to be these things in here. Now, what else now can we do? Look, now from here, what we are going to do now, we are going to continue and say now, what is going to be our now our CM? Now, what is going to be our side CM? Right? We are then going to find out what is going to be our side CM. And now let's see how can we then find out our side CM. So now if you can check there, for you to find side CM, there are many ways in which you can do. Look, you already also have what is going to be what? You already have also this one from here up until here, right? You already have that one, those two lines. So what you are going to do now, you are going to come back and say now, your CM, it is going to be given by what? your cm, it is going to be given by your 2884 comma what comma 39. That is going to be your cm, which means this distance from here, this distance from here up until here, this is same as 2884.39. That is going to be the totality of that particular distance. And now that we've calculated, then now we can calculate what is going to be our CP. And now for us to calculate the value of our CP, it is going to be simple now, because you're having this side, you're having this side, right? Now you are also having 19 degrees, right? And actually from here, you are still in a position to calculate it. Look, one could have just easily used tan. One could have just easily used tan and said, this is your tan, which is opposite over your adjacent, and then you could have found your answer, right? And one else can also use the opposite, which is your sine, which is opposite over hypotenuse, right? And the opposite side that you are given. And I believe the easier route or the safer side that we can do to calculate this, it is to exclude just your cm and use your MP instead. So now what is it that you are going to do now from here? You are going to say, in order to calculate this, now your CP here, now you're going to say your angle. Remember, this is the angle, this is the side opposite to that angle, and this is the adjacent side, right? So which means basically you can still say tan of 19.29 degrees. It is going to be what? And this is your tan. So tan is opposite, and your opposite is CP, right? It is CP over, now what is going to be the adjacent here? The adjacent is going to be the 3100, or rather 3100, isn't it so? And now when you cross multiply, look, which means your CP, it is going to be 3100 tan of 19.29 degrees. So therefore your side CP, that you are going to calculate in there, let's see, it's going to be 952 comma 86 meters, right? So which means your side, what now, this side that you are looking at, which your side CRP, it is going to be 952.80 cent, right? Now hopefully this will make sense to you.